Let's start with the history of fluoroscopy. Earlier, the fluoroscopy used to emit yellow-green spectrum of light, therefore known as green stream. The emission was so faint that fluoroscopic examination was carried out in dark room. Therefore, radiologists should wear red goggles. Why? For at least 30 minutes. Why? Because there should be dark adaptation of the eye. Therefore, 20 to 30 minutes prior to examination they should wear. Moreover, beam of this dark and fainted image used to stimulate rods of the eyes. Therefore, there will be poor visual acuity and decreased contrast. This is the problem. Now, how is this problem solved? It is solved by image intensifier. This image intensifier will produce bright image. This bright image will stimulate cones and therefore improve image quality. And therefore there will be increased image quality, increased visual acuity and increased contrast. Let's see the image. We can see X-ray housing below, giving out X-rays. It is going and hitting the image intensifier. There is a switch and video monitor. We will discuss each and everything and the principle in detail. Let's start with image intensifier. We'll draw the diagram. First we'll draw the housing. Now we'll draw the input phosphor at one end and output phosphor at the other end. Then near the input phosphor, green color, we'll draw photocathode, then electrostatic lens in the blue color and anode at the opposite end. Now we'll study the principle. X-ray beam is produced. It will hit the patient and then it will go to the image intensifier. This image intensifier, first it will interact with the input phosphor. With input phosphor, this X-ray will be converted into light and this light will then hit the photocathode. This photocathode will then emit electron. Because there is a potential difference, anode is at the other hand, electron will be accelerated towards anode and these are focused by the electrostatic lens. Now these electrons will hit the outer phosphor and then there will be emission of light. Now the light emitted by the outer phosphor will go and through the tubes will go either directly to the television monitor or through lens and monitor through the optical monitor. This will then form the image. Therefore, the problem which was earlier in the fluoroscopy, that dark room was needed, it is solved by image intensifier by giving out light, bright image which will stimulate the cones and increase the visual acuity and image contrast. Now let's start with each component of image intensifier. First, input phosphor. It was earlier made up of silver activated zinc cadmium sulfate, but nowadays we use cesium iodide. Now why we use cesium iodide? Because there is vertical orientation of cesium iodide crystals. Therefore, it will prevent diffusion of light. Second point is there can be greater pathogen density, around 3 times of cesium iodide than that of the zinc cadmium sulfate. And third point is more favorable atomic number of cesium iodide. Therefore, absorption percentage would be greater. Second component is photocathode. Photocathode is made of antimony plus cesium. Light will come, interact with photocathode, emit the electron. The electron emitted will be directly proportional to the intensity of the light incident upon the photocathode. We know that from X-ray will first interact with input phosphor, there will be production of light. Now how much light will be produced? Same directly proportional, the electrons will be produced by the photocathode. electrostatic focusing lens. What does this do? The electrons which are produced is attracted towards the anode due to potential difference. This will focus the beam. Next part is anode. This is the positive end. Negative end electrons are produced, accelerated towards the anode. Therefore, anode is at the other end. Output phosphor. It is made up of silver activated zinc cadmium sulfate. The main point to remember is that the diameter of the output phosphor is much less than input phosphor, which we can see in the diagram also. Some parameter which we need to remember. Brightness gain. Brightness gain is magnification gain into flux gain. What is magnification gain? Input phosphor diameter divided by output phosphor diameter, the whole square. And flux gain is increases brightness by the factor of 50. Therefore, for each light photon, 50 light photon is emitted by the output phosphor. This multiplied by the input phosphor is the brightness gain. Let's see this principle in the image. First, we'll draw the image intensifier. Then we'll draw the table. In this table, patient will lie down. Therefore, we'll draw patient also. Below this, the table, there is housing of X-ray tube. Now, from the housing of the X-ray tube, X-rays will be produced, hit the patient. This will go to the image intensifier. Through this, it will go to the monitor. Now let us revise everything. Earlier the fluoroscopy was in the dark room, therefore it was very difficult. Rods were stimulated. To solve this problem, we developed image intensifier, through which we have got light or brighter image which stimulates cone and improve the image quality. What we did, this is because of the image intensifier. Now how this will work? First, from the X-ray housing, X-rays will be produced. It will go and hit the table. In the table, the patient is lying down, so it will hit the patient, and the transmitted X-rays will go above and hit the image intensifier. In the image intensifier, first part it will hit is the input phosphor. This input phosphor will convert X-ray into light. This light will go and hit the photocathode. Light will get converted to electrons, which will be directly proportional. These electrons will go towards anode, accelerated due to potential difference. It will be focused by the electronic focusing lens. In the anode side, there is phosphor whose outer phosphor whose diameter is very less than the input phosphor. This electron will then be converted into light by the output phosphor. This will go through the wires to the monitor and we will see the image. Some parameters used are brightness gain, which is magnification gain into flux gain. Magnification gain is input phosphor divided by output phosphor diameter, the whole square, and flux gain is the factor which increases brightness by a factor of 50.